Okay, so this is the Unit 6 test review, and I'm going to get through as much as possible. Okay, so first, it says to find the interior angle sum. Interior angle sum for each polygon. So if it says sum, the sum means it's going to be a larger number, right? It's going to be all of the angles added together, the sum. So the sum of the interior is 180 times n minus 2. Now, if this was a regular polygon and I wanted each interior angle, I would take that and I would divide it by n. But for sum, you don't divide it. All right, so a regular pentagon. So if we have a pentagon, penta tells us that n equals 5. Pentagon has 5 sides, so n equals 5. So the sum of the interior of a pentagon equals 180 times 5 minus 2, or 180 times 3, which is 540 degrees. So all pentagons, all 5-sided figures have a total of 540 degrees inside. So S stands for sum, the little I stands for interior. And then the sum of the interior of a regular 20gon, so this means that n is 20. So it's going to be the sum of the interior equals 180 times n minus 2. 20 minus 2 is 18. And 180 times 18 is going to give me 3,240 degrees, which is a lot. But it's a 20-sided figure, so there's a lot of sides there. And then for a 24gon, so the 24 tells me that's n is 24. So the sum of the interior equals 180 times n, which is 24, minus 2. So 22. 180 times 22 gives me 3,960 degrees. And then a regular heptagon. Hepta is 7. So n equals 7. The sum of the interior equals 180 times 7 minus 2. So 180 times 5. So the sum of the interior of a heptagon is 900 degrees. And if you want to add those prefixes like hepta, penta, whichever, deca, dodeca, to your yellow paper, I'm okay with that too. I don't know how much you're going to need that on the test. I don't really recall needing it, but you can just in case if you would like. All right, that was the sum of the interior. So the next section, it says each interior angle. So that's each one of them. One interior angle, not the sum. So first you have to find the sum and then divide it by the number of angles, and for that it has to be regular. So on the sum of the interior, it doesn't matter if it's regular or irregular. That part doesn't matter for the sum. But you can only use the formula for each interior angle if it's a regular polygon, because that means it's divided evenly amongst all the angles. If it's not regular, then you have to come up with a different method. So this is each interior equals, on the numerator is the sum, so 180 times n minus 2, and it's going to be divided by n, the number of angles that you're working with. So you find the sum and then split it evenly amongst all the angles. All right, so this one is a regular 11-gon. So n equals 11. So each interior angle equals 180 times n minus 2. So 11 minus 2, that's 9. Divided by n is 11. So 180 times 9, and then divide it by 11. So it's going to be 1620 on top, divided by 11 angles. So the sum is 1,620 degrees. We split it amongst 11 angles, then it's 147.3. So each angle in that 11-sided figure has a measure of 147.3 degrees. All right, so I'm not going to do every single one of these because I think you get the pattern now. 17 gone is going to the same thing, but substitute in 17 for n. Octagon, octa is 8. So each interior of an octagon, a regular octagon, will be 180 times 8 minus 2, and then we're going to divide it by 8. So it's 180 times 6, which is 1,080, or 1080. And then we divide it by 8, so each one of them is 135 degrees. And why I'm thinking of it right now, you don't need to worry about number 20, 21, or 22. You will not have questions like that where you have to graph on the test. So don't worry about 20, 21, or 22. And so number 8, it says decagon. I'm going to go with its n is 10 for a decagon. And leave it there. I'm not going to worry about solving for that one. But if you want to know, the answer for this one is 144 degrees. So each interior equals 144. But I just want to cover as many type of problems as I can. So we're going to move on. All right, now it says find the measure of each exterior angle. So if when we found each interior angle, so one interior, and now it says to find one exterior, each one. So we're going to take the total, the sum of the exterior, and divide it by the number of angles, and that's how much each angle is going to be. Remember I said whenever we did the exterior angles, it's circumscribing the figure. So you're drawing a circle around the figure. So it doesn't matter what the figure looks like, you're drawing a circle around it. And a circle has 360 degrees. So the sum of all exteriors, since on all of them we're drawing a circle around it, is 360. The sum of the exterior for all polygons is 360. But we don't want the sum. We want each one of a regular. It does have to be regular. So each exterior angle equals 360 divided by n. If it asks for the sum of the exterior, that would be 360. That's a really easy question. But this wants each one. So a dodecagon is 12. So n equals 12. So each exterior angle of a dodecagon is going to be 360 degrees divided by 12, which is 30 degrees. And then a 14-gon, so n is 14. So this is going to be 360 divided by 14, and that's 25.7 degrees. So the larger the n value gets, the smaller the angle is going to get. Because if you have more angles, they're all adding up to a set number of 360. The more you have, the smaller they have to be. A nonagon is 9. That's n equals 9. So this one is 360 divided by 9. And that gives you 40 degrees. And then a 16gon, 360 divided by 16. So we know it's going to be smaller than the 14gon. It's 22.5. All right, so that's using those formulas. And then on page 2, we start with different figures. So we're going to find the measurement indicated in each parallelogram. It's a parallelogram. So on your yellow paper during the test, this is when you would review your properties of parallelograms and then look to see what is given, label it in the picture, and see which property is going to help you solve. So I have a parallelogram, and it tells me that TP equals x plus 2. Here's TP, all right? And then it says that TV is x plus 10. So TV is x plus 10. And so find that in the picture. It's the entire length of that diagonal. So both are on the same diagonal. The orange one is part of it, and the green one is the whole thing. So if we look at our characteristics of parallelograms, oh, also it says to find TV. So identify what you're solving for. One of the characteristics of parallelograms is that the diagonals bisect each other. So if the diagonals bisect each other, that means it's been cut in half and those two pieces are equal. So then if I wanted an equation, I could say 2 of the orange piece, 2 of TP, it would take 2 of those to equal the green one, TV. If I had 2 orange ones, it would be the same length as the green one. And then I can change out TP for the values, x plus 2. And I can trade out TV for the value x plus 10. And now I have an equation to solve. All right, so solving this equation, I'm going to take 2 and distribute it into the parentheses. So now I have 2x plus 4 equals x plus 10. I need to solve for x before I can find TV. I have 2x and I have 1x on the right. I need to get them together, so I'm going to subtract x. So now I have x plus 4 equals 10. So I'm almost there. Subtract the 4. And now I know that x equals 6. All right, so x equals 6, but it doesn't say solve for x. It says solve for TV. And make sure on the test you pay attention to whether you're solving for the side length or angle or if you're asked for x. Because don't just stop. If I was making the test, which I do, I would, and this was multiple choice, I would probably put 6 as a multiple choice answer just to see if you're paying attention. Might call it a dirty trick, but pay attention. It says to find TV. TV is not 6. TV equals x plus 10. So I'm going to put a blank plus 10, and I know that x is 6. So instead of putting x, I'm making it 6. 6 plus 10. So that means that TV is 16, not 6. All right. Number 14 is similar, but different. All right, still parallelogram. This time we have CR is x plus 7. So find CR. There it is. And RA is 2x. Where's RA? It's this side. All right, so we're still talking about diagonals, but this time we have two halves of the same diagonal, and we know diagonals bisect each other in parallelograms. So those two pieces are equal to each other. The pink piece equals the blue piece. So I can say that the pink one, RA, equals the blue one, CR. And I have a value for RA, that is 2x. So instead of RA, I'm making it 2x equals CR. But instead of CR, there's a value for that, so x plus 7. And now I can solve for x. All I need to do is subtract x. Get the x's together on the left. Now I have x equals 7. But I'm not finished because it doesn't say what is x. It says find CR. So make sure you solve for the correct thing. CR equals x plus 7. And I know that x is 7, so I plug it in. 7 plus 7. So CR equals 14. Okay. 15 and 16, these are pretty much the same problems. I'm only going to do one of them. They're just going different directions. It still says that these are parallelograms, and this time it does say solve for x. So I don't need to find the length or the angle of anything. I just need to solve for x. So looking at number 15, you have to think which property of parallelograms from my yellow paper can I use to solve for x? Well, we all know that parallelograms have opposite sides are congruent. So that means that 4x minus 4 equals 3x plus 3. And so I write that. 4x minus 4 equals 3x plus 3. And then just solve. Need my x's together, so I'm going to subtract 3x. So x minus 4 equals 3. And then I add 4. So x equals 7. But this time I'm finished because this problem just said to find x. I didn't have to solve for a side. But if it asked me for a side, it wouldn't matter which one I plug it into because they should both come out to be the same value. All right. Number 17. Again, I'm still dealing with parallelograms. So it's important you pay attention to which shape you're working with, what kind of polygon. This time it says solve for x and y. Sometimes you can only, you don't have a choice really of which one you're going to solve for first. For number 17, I do have a choice. I can, because of the way the problem is set up, I don't need one of them to find the other. So I see the z angle. Remember, z angles are z same. And so anytime I see them, I like to start there because it's easy for me. I know that one. Z angles are the same, which means that 24 is equal to 4x. The alternate interior angles theorem. If you have a transversal that cuts through two parallel lines, they make alternate interior angles, and those angles are congruent. It also happens to make a Z. So I know that 24 equals 4x. And that's a pretty easy problem to solve. All I need to do is divide it by 4. Whoa. To find out that x equals 6. So there's half of my answer. This says solve for x and y. So I still need to find out what y is. But if I look at the way, if I turned my z, basically, and I look at the other set of parallel lines, because a parallelogram has two sets of parallel lines, so that means it has two sets of z angles. So this is the same transversal. But now my z is that way. And so 32 degrees equals y minus 10. Mm-hmm. Mm-hmm. Yes, alternate interior angles are congruent. And then again, this is a pretty easy one to solve. All I have to do here is add 10 to get y by itself. So 42 equals y. Okay, so then on number 8, that one, I don't think that one's on your paper, is it? It is. Don't worry, that was an honors question I forgot to erase. It has a really nasty fraction in it. You will not see anything like this, so don't even worry about that. Apologize for that being there. I did it. The answer, I did it last period. Was 100, I rounded to 108. But when you get x is 17 over 14. And then you plug it back in times 89 and you get the angle E is 108. All right, so number 18 says that ABCD is a rhombus. There's no picture, so you know what I want to do first is draw a picture. Because you should always draw a picture. Because if you don't, then how are you going to know? How are you going to identify or label your figure if you don't draw a picture? There'll be nothing to label. So I sketch a rhombus, and I know these go alphabetically, the alphabetical order, or not, I'm sorry, not alphabetical. Where you read left to right, and so you label clockwise, left to right. So A, B, C, D. And then it tells me that AB is 2y plus 10. So AB is the top piece. And then it says BC is 3y minus 20. It's over here. Find the length of CD. So I want to find that one. All right, so now that I have my problem set up, look at my yellow paper for properties of rhombi. What is the property of a rhombus that applies to this problem? What is special about a rhombus? A rectangle has 4 identical angles. A rhombus has 4 identical sides. So all 4 sides are the same. So it doesn't matter which side I solve for. As long as I solve for one, I know what they all are. So I could say that AB is equal to BC. And since I know that AB is 2y plus 10, and BC is 3y minus 20, I can solve for y, plug it back in, and whatever that is the same as DC. All right, so I have 2y and a 3y, so I'm going to subtract the 2y. Take baby to mama. The smaller one goes to the big one. So 10 equals y minus 20. If I add 20, then y is now by itself. So 30 equals y. So I figured out y is 30, but I don't just want y. I want to find out a side length, so it doesn't matter which one I pick. I'm just going to pick AB. If you chose BC, that's perfectly fine. 2 blank for y plus 10. And I said that y is 30, so I plugged that in for y. So AB equals 60 plus 10. So AB equals 70. And since all the sides are congruent, that means that CD also equals 70 because it's a rhombus. All right, I want to get through one more for this video. Again, I don't have a picture, but it tells me MATH is a rectangle. So polygon, MATH. MATH. And it's a rectangle, so I know all 4 angles are 90 degrees. Let's see what it says. Oh, but this isn't even talking about those, is it? It says that MT is 2x plus 10. So there's MT. And it says HA is 6x minus 14. All right, so it doesn't care about the angles for this problem. We want to find HA. So what property of a rectangle can I use to solve this problem? Well, for rectangles, the diagonals are congruent. So that means I could say they're equal to each other. So 2x plus 10 equals 6x minus 14. For a property of rectangles is that diagonals are congruent. So I subtract the 2x. And I get 10 equals 4x minus 14. And then I add the 14. So 24 equals 4x. I have to move this up here. Okay, and then divide by 4. So 6 equals x. So x is 6. It did not ask me for x. It says find the length of HA. And it doesn't matter which diagonal I solve for because I know that they are congruent, but I'm going to go ahead and go with HA because that's what it says. So HA equals 6 times x, or 6 times blank, minus 14. And I know that the blank is what I just solved for. X is 6. So HA equals 6 times 6 is 36, minus 14. So HA is 22.